The microprocessor is commonly referred to as the brain of a computer. This comparison suggests that a circuit fabricated on a piece of silicon is capable of human thought processes. However, this is not an accurate statement. Circuits can be designed to perform many useful functions, but they cannot think for themselves. A microprocessor is a digital logic circuit. Transistors are connected in specific patterns to form elements that can perform useful functions. The basic elements from which all digital circuits are designed are the AND gate, the OR gate, the inverter, and the exclusive OR gate. The schematic gate symbols have two inputs and one output. Voltage levels are either low or high and are represented as 0 and 1. If we make both inputs on a AND gate 1, the output will be 1. Either or both inputs on the OR gate can be 1, and the output will be 1. The inverter simply inverts a 1 to a 0 or vice versa. The exclusive OR gate requires that only one of the inputs can be 1 for the output to be 1. If both inputs are 1, the output will be 0. This is binary logic, and everything in a microprocessor works like this. If we want to add numbers, the numbers must be in binary form, like this, 0 or 1. Assume that we want our microprocessor to add the numbers 3 and 4. We can't input these numbers directly because they have to be binary, so we count in binary. 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. These binary numbers represent counting from 0 to 7 in decimal format, which is how we all learn to count in school. So we input binary number 1, 1. That's 1, 1, not 11, and 1, 0, 0 to the arithmetic logic unit in our microprocessor, and it outputs the binary number 1, 1, 1, which is 7 in decimal format. Microprocessors operate according to an instruction set. So if we want the ALU to add numbers, we must also instruct the processor to fetch the numbers from the keyboard or from a memory location or from a register on the silicon chip. Then we must instruct the processor to send this data to the ALU and tell it to add. Then we will instruct the processor to send the result of the add process to the monitor or printer or to a specific memory location so another program can use it. When writing computer code or an application, this is all necessary for the code to run correctly. One mistake and it will fail to execute the process. Since everything is binary in a microprocessor, the instructions must also be in 0 and 1 format. This can be very difficult to deal with when writing a program, so high-level forms of programming are used and then converted to binary machine code by compilers. Let's take a look at an old 8-bit microprocessor die to see how these things are manufactured. This view is the entire microprocessor enlarged. This close-up section shows a bonding wire attachment pad top center and the conductor pattern which connects the individual transistors to each other in the circuit. The complete circuit consists of 3,500 transistors, and the process technology is 10 microns. Transistors are formed by applying etch resist to the silicon wafer and then exposing it to light through the photomask. Development of the resist layer exposes areas which are then modified by diffusion or ion implantation to become semiconductor regions. This process is repeated to create the transistors and then the metal layers are formed to create the circuit pattern.